Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. The topic we are treating today is algebraic expressions, and this is the first video on algebraic expressions. Here are the objectives we look forward to achieving at the end of this topic. At the end of this topic, you should be able to add, subtract, multiply, and divide algebraic expressions. You should be able to expand and factorize algebraic expressions, and you should be able to factorize quadratic trinomials. Now, what are algebraic expressions? Algebraic expression is a collection of letters and symbols combined with at least one of the following operations: addition, subtraction, multiplication, and division. So for example, we have the expression 4a plus b minus c. Now we can see from here that we have a collection of letters and symbols, and they are being separated by either the bullet point told us that it can be separated by at least one of the following. So from here you can see that 4a is separated from b by an addition sign, and b is separated from c by a subtraction sign. So an example, something like this is what we refer to as an algebraic expression. Now another example is 3x over y. Now we can see from here that we have 3s as the numerator and y as the denominator. Now 3s is being separated from y by a division sign, so this also qualifies as an algebraic expression. In algebra, letters are used to represent numbers. When letters represent different numbers, they are called variables. Sometimes numbers are attached to these letters. These numbers are called coefficients. So if you look at the example here, we can see that we have letters and numbers in there. And this point is telling us that sometimes letters are used to represent numbers, and these letters are called variables. So you can see in the first example, we have letters A, B, and C. Now these A, B, and C represents numbers. So these letters here are called variables. Sometimes numbers are attached to these letters. So you can see from in the first instance that we have 4 being attached to a. So in that case, we call 4 as the coefficient of a. 4 is the coefficient of a. Now, if you have a letter and there is no number attached to it, it means that the number attached to it is 1. We don't write it. That's why it's written as that. So these numbers are called coefficients. Let's proceed and learn more about algebraic expressions. When a number stands on its own in an algebraic expression, it is called a constant. For example, considering the expression 2s plus 2, s is the variable, 2 is the coefficient of the variable s, and 5 is the constant term. So we can see from this example that we have 2 being attached to s. So s in this case is the letter. Remember, we said that the letters are called the variables. So in this case, s is a variable. Now 2 is directly attached to s. So 2 is the coefficient of s, and 5 is the constant term because we have no letter being attached to it. Let's proceed and learn more about algebraic expressions. Terms in an algebraic expression are separated by addition or subtraction. So if you consider the example that we have here, you can see that we have 2s on one side, then we have 5 on one side, and 2s is being separated from 5 by an addition sign. Now when that happens, we say that 2s is a term and 5 is a term. That's why the bullet point here is trying to tell us that terms in algebraic expressions are separated by addition or subtraction. In algebraic expressions, s multiplication and divisions are usually not written. So if you have m times n, it's written as mn. If you have a divided by b, it's written as ab. So we can see that in the previous examples that we took, we had, for example, we had 2s. 2 and s were written together. So what it means is that this is actually 2 times s. But because we usually do not write multiplication in algebraic expressions, 2 times s is written as 2s. In the first slide too, we saw that there was an example like 3s over y. This is actually 3s divided by y. But because we usually don't write division in algebraic expressions, 3s divided by y is written as 3s over y. Terms in an algebraic expression may consist of a number, a letter, and powers of numbers. Now let's take an example to illustrate this. So we've already seen what a term is. We have seen that terms are the parts in algebraic expression that are separated by additions or subtractions. So you can see from here that in this case 5 is a term. In this case 5 is a term, s is a term, y squared is a term, 4ab cubed, 4ab raised to the power 4 is also a term. So we are saying that a term in an algebraic expression may consist of a number, for example 5. So in this case 5 qualifies as a term. It may consist of a letter, for example we have s here, s is also a term. It may also consist of powers of numbers. So you can see from here that we have the letter or variable y, but it's raised to the power 2. So a term can also contain a power of number. Sometimes all these come together and also form one term. An example is what we have here, 4ab raised to the power 4. So you see that in this term we have 4, which is a number, we have a letter, and we also have a power of a number here. So all these can happen or can come together to give us a term. In a term, the numbers comes first, followed by the letters in alphabetical order. So if you have a term in an algebraic expression where you have a number and a letter, the number must come first, then the letters will follow in alphabetical order. So for example, we have 4ab raised to the power 4. So in this case, the letter in the term, which is 4, must come first. Then the number in the term, which is 4, must come first. Then the letters must follow in alphabetical order. So A comes before B. So we have A, B raised to the power 4. So it is not written as 4b raised to the power 4a. Rather, it is 4b raised to the power 4. So the numbers come first, then the letters will follow in alphabetical order. Terms with the same letters and power of numbers are called like terms. Now this is a very, very important thing. I'm going to highlight this for you to see. They are called like terms. So I'm going to highlight like terms. Then I will explain what that means to you. What that means. So if we want something to qualify as a like term, we are saying that terms with the same letters and powers of numbers are called like terms. So for two terms to qualify as like terms, they must 1. Have the same letters. 2. They must have the same power of numbers. Now, this is what I mean. Let's take the term s of an algebraic expression. Then we take another term which is also s of the same algebraic expression. Now we can see that this term here is s. This one also is s. The letter here is S, the letter here is also S. Now S here is written with no power on top, which means that it's raised to the power 1. Any number or letter raised to the power 1 is the same letter. This term is also written with no power, so it also means that that one is also raised to the power 1. Now we can see that the letter in this X here, the letter in this term here is X. The letter in that term is also X. The power of this term here is 1. The power of this term is also 1. So they have the same letters and they have the same power of numbers. So we say that S and S are like terms. Here's another example. Let's say we have 3A. Then we have 2A. Remember, when we are talking about like terms, our interest is not in the numbers or the coefficients of the letters. Our interest is in the letters. For two terms to qualify as like terms, we have seen the two conditions. They must have the same letters and they must have the same power of numbers. So we are going to consider this term here. The first term is 3A and the second term is 2A. Our focus is not on the coefficients but on the letters or the variables. So the first letter here we have A. It's raised to the power 1 because we don't see any power there. Now the second one, we also have the letter A. It's also raised to the power 1 because there's no coefficient there. Now they satisfy the two conditions. They are the same letters, A. They have the same powers, raised to the power 1, raised to the power 1. So we say that 3A and 2A are like terms. Now let's take this example. Let's say we have y raised to the power 2. Then y raised to the power 3. In the first instance, we see that we have y raised to the power 2. The letter is y. The power of the number is 2. In the second instance, we see that the letter is y. The power of the number is 3. So it satisfies the first conditions. The letters are the same. You have y. But the powers are not the same. The power of the first y is 2 and the power of the second y is 3. So y raised to the power 2 and y raised to the power 3 are not like terms. In the same way, if we have s raised to the power 3 and b raised to the power 3. Now, even though they have the same powers of numbers, the letters are not the same. The letter here is S, the letter here is B. So S raised to the power 3 and B raised to the power 3 are not like terms. Remember, for two terms to qualify as like terms, they must have the same letters and the same power of numbers. This is very, very important. We are going to use this in the next video. Thank you so much for watching this video. In the next video, we are going to learn how to add and subtract algebraic expressions. The topic we are treating today is algebraic expressions, and this is the second video on algebraic expressions. In the first video, we learned what algebraic expressions are. We learned how to identify a term in an algebraic expression, and we also learned how to identify like terms. In this video, we are going to learn how to add and subtract algebraic expressions. So let's begin. Addition and subtraction of algebraic expressions. Only like terms can be added or subtracted. So as we saw in the previous video, there may be like terms in an expression, and this point is telling us that you can only add or subtract like terms. Now, how do we proceed? To add or subtract, the first thing you must do is to group the like terms in the expression. So for example, if we are to consider this expression here, 4x plus 6a minus 2x plus 5a. So we have this term here 4s, we have this term 6a, we have this term minus 2s, and we have this term 5a. If you are to add this or subtract this expression, the first thing you must do is to group the like terms. As we saw from the previous video, 4s and minus 2x are like terms, so we are going to group them together as we have here. Then 6a and 5a are also like terms, so we group them together. So this is what we mean by grouping like terms. You bring the terms that are like together. Then from there, you add or subtract the coefficients of the variables. In the previous video, we learned that the numbers attached to the letters are the coefficients of the letters or the variables. So in this case, the number attached to s is 4. So 4 is the coefficient of s. The number attached to this s is minus 2. So minus 2 is the coefficient of s. The number attached to a is 6. So 6 is the coefficient of a. And in the last term, the number attached to a is 5. So 5 is the coefficient of a. This point is telling us that we have to, after you group the like terms, you should add or subtract the coefficients of the variables. So if it is subtraction, as we have in this case here, we have 4x minus 2. What you do is you subtract the coefficients. So we are going to subtract minus 2 from 4 since we have 4x minus 2. So we are going to have 4 minus 2. Then in this case here, you also add the coefficients. We are going to have 6 plus 5. So if you are adding this, you add or subtract the coefficients. So in the first instance, we are subtracting. So we have 4 minus 2, and that will give us 2. Then you pick one of the variables. Since we have s here and s here, you pick one of the variables. So you are going to have 2s. In the second instance, you have 6a plus 5a. So we add the coefficients. So we add 6 to 5. We are getting 11. So you have 11a. Remember, from here, we do not add a to a. The points told us that we add or subtract the coefficients of the variables. We don't subtract the variables. Once again, s is the variable in this case and 4 is the coefficient. So after you've grouped the like terms, you add and subtract the coefficients of the variables. Now let's take some more examples and get conversant with this. So we have been told to simplify the following. We have been given a, b, c, and d. So let's begin by simplifying a. A is 22x minus 4sy minus 7s plus 3sy. So as we saw in the previous slide, the first thing we must do is to group like terms. So clearly we can see from this that the like terms are 22s and 7s. They are like terms. Then minus 4sy and 3sy are also like terms. So after we've grouped the like terms like this, the next step to do is to add or subtract the coefficients. So in the first instance, we are having 22s minus 7s. So you are going to subtract 7 from 22. So you are going to have 22 minus 7. In the first instance, in the second instance, we have minus 4sy plus 3sy. Once again, we are adding the coefficients. So we are going to get minus 4 plus 3. So in the first instance, we have 22s minus 7x. So you are going to get 22 minus 7. That will give us 15. So you are going to have 15s. Remember that we are subtracting the coefficients. Now in the second instance, we are going to have minus 4 plus 3. We know that minus 4 plus 3 will give us minus 1. So in actual sense, we were supposed to have minus 1 sy. But if you have minus 1 sy, it's written as minus sy. So whenever a term is written and there is no coefficient attached to the term, it means the coefficient there is 1. So we see from here that we have minus sy. Minus sy is the same as minus 1 sy. So minus 4 plus 3 will give us minus 1. So we are going to have minus 1 sy, which is written as sy. So once again, you group the like terms. So we have 22s and 7s grouped together here. Then we have minus 4sy and plus 3sy grouped together here. You subtract, in this case you are subtracting the coefficient, so you have 22 minus 7, that will give us 15, so we have 15x. Now in this case it is addition, so minus 4 plus 3, we know that minus 4 plus 3 will give us minus 1. Then we have xy here, so we pick one of them, so we have minus 1sy, and minus 1sy is written as minus sy, so our correct answer is 15x minus sy. I'm going to clean here so that we can continue on what we are doing. So let's take the next example, B. We have 3c squared plus 7cd minus 4c squared plus 5d. So once again, the first thing we need to do is to group like terms, and we can see clearly from here that 3c squared and minus 4c squared are like terms. Those are the only like terms that we have, because 7cd and 5d are not like terms. Remember that we said in the first video that for two terms we considered as like terms, they must have the same letters, and the letters must also have the same power of numbers. Now here the letter or the variables here are cd. The letter or the variable here is only d, so they are not like terms. So we group the like terms and we leave the unlike terms. So when grouping the like terms, I chose to write the unlike terms first. So we have 7cd plus 5d written first. Then the like terms, which are 3c squared minus 4c, will also be written. Then from there, our next step is to do the addition or subtraction. So in this case, we can see from here that since 7cd and 5d are not like terms, we cannot add them, so they are written just like that. But when we come here, we have 3c squared and 4c squared being like terms, and the operation separating them is minus, so we are going to have 3 minus 4. Remember we said that we will add or subtract the coefficients, so 3 minus 4. We know that 3 minus 4 is minus 1. So actually we are going to get minus 1 c squared. But just as we learned in the first example, minus 1 c squared is the same as minus c squared. So the answer for B will give us 7cd plus 5d minus c squared. We are not adding 7cd to 5d because they are not like terms. Let's take the next example, C. And C is giving us 14y minus x plus 2y minus 6s minus 5y. So once again, the first thing that we need to do is to group the like terms. And if we are grouping the like terms here, you will see that we are going to have 14y plus 2y minus 5y as like terms. Then minus x and minus 6s as like terms. Now, after we group the like terms, the next thing that we need to do is to add or subtract the coefficients. So you can see from here that with the first two is addition, then the third one is subtraction. So we are going to have 14 plus 2, which will give us 16. Then 16 minus 5, which will give us 11. Then in the next instance, we have minus x minus 6s. Now once again, remember that I said whenever a variable is written and you don't have a coefficient in front of it, it means that the coefficient there is 1. So with minus x, it actually means that the coefficient there is 1. So you are having minus 1 minus 6. We know that minus 1 minus 6 is equal to minus 7. So if you are simplifying this, We know that 14 plus 2 is 16, minus 5 will give us 11, so we have 11y. Minus 1 minus 6 will give us minus 7, so we have minus 7s. Now let's look at the last example, D. And D is giving us 7a squared plus 5a minus 7a raised to the power 4 plus 5a minus 2a raised to the power 4 minus 4a minus a raised to the power 4. So what we have to do once again, remember the first step. The first step is that you group the like terms. So we group the like terms. 7a raised to the power 4 minus 2a raised to the power 4 and minus a raised to the power 4 are like terms, so we group them together. Then 5a and minus 4a are also like terms, so you group them also together. Remember, when you are grouping the like terms, we don't change any of the signs, we just change the position. So we have 7a here, so you leave it there. Then minus 2a is a like term, so remember when it's coming, you already have a minus there, so we write it as minus 2a. Minus 2a raised to the power 4 is already minus, so you write the minus there. Then minus a raised to the power 4 is already minus, so you also write the minus there. We just change the positions, we don't change the sign. 5a is positive, so plus 5a. Then 4a is negative, so minus 4a. Remember that a raised to the power 4 and a are not like terms. In the first video, we said that for two terms to be considered as like terms, they must have the same letter, 1. 2, they must have the same power of numbers. Now we can see from here that even though they have the same letter a, this a here is a raised to the power 4, and this a, the a attached to the 5, is a raised to the power 1. So they don't satisfy those two conditions that we give. For two terms to be considered as like terms, they must be the same letter. So in this case, it's a and a is true, but the power of this a is 4 and the power of that a is 1, so they are not like terms. So after you've grouped like terms, we move on to our next stage. The next stage says that we should add or subtract the coefficients. So what you are going to do is you are going to add the coefficients. We are going to add the coefficients of the first part, then we add the coefficient of the second part. So if you are adding the coefficient of the first part, you have subtraction and subtraction. So in this case, you are going to subtract. So you are going to have 7 minus 2 minus 1. Remember, a raised to the minus a raised to the power 4 is the same as 1 a raised to the power 4. So if you are subtracting, you are going to have 7 minus 2 minus 1. We know that 7 minus 2 is 5, minus 1 is 4. So you are going to have 4a raised to the power 4. Then we come to the second part. We have 5a minus 4a. So we are going to have 5 minus 4, and that is 1. So we are going to have 1a here. And once again, remember that if you have 1a, it is written as a. So our final answer is going to give us 4a raised to the power 4 plus a. Once again, remember that a raised to the power 4 and a are not like terms, so we cannot add it. Now, the table below shows some expression with corresponding correct answers and common mistakes that students usually make. So from what you've learned, you've come to see that if you have the expression 3x plus 4x as we have here, the right answer is 7s, not 7s squared. That is a mistake. If you have the expression s plus s, the right answer is 2s, because the first s has a 1 in front of it, the second s has a 1 in front of it. So what you do is that you add the coefficients, then you pick one of the variables. So you have 2x. So s plus x is 2s, not s squared. That is a mistake. S plus y. We know that x and y are not like terms. So just as we learned, you cannot add terms that are not like. So s plus y is s plus y, not sy. In the same way, 3s squared minus s squared will give us 2s squared, because you have 2 minus 1. Then you pick one of the s squared, which will give us 2s squared. So 3s squared minus s squared is 2s squared, not 2s. When we are subtracting, our main focus is on the coefficients, not the variables. 2s squared minus 3s squared will give us minus s squared, not minus x. If you look at the last example, 4s squared plus 2x, we can see from here that s squared and s are not like terms. So you cannot add 4s squared to 2s. So 4s squared plus 2s, the right answer for that is 4s squared plus 2s, not 6s raised to the power 3. That is wrong. So take note of these and pick more examples on additions and subtraction of algebraic expression. Now make sure that you don't commit any of the mistakes that I've shown in this table. Thank you so much for watching this video. See you in the next video, where we will continue on our studies on algebraic expressions. In that video, we are going to learn how to multiply algebraic expressions. The topic we are treating today is algebraic expressions. This is the third video on the topic. In the previous video, we learned how to add and subtract algebraic expressions. In this video, we are going to learn how to multiply and divide algebraic expressions. Now, multiplication and division of algebraic expressions. To multiply algebraic expressions, 1. Group the coefficients and variables. So when the expression is given to us, all that we need to do is to first group the coefficients and variables. Now, what does that mean? If you have the expression 3x times 2x, when we group the coefficients and variables, we are going to have 3 times 2 times x times x. Remember, in the first video, we said that the expression 3x is the same as 3 times x. And the expression 2y is the same as 2 times y. So we already have the multiplication here. So times. So 3x times 2y is the same as 3 times x times 2 times y. So all we need to do is to group the coefficients and the variable. So we group the coefficients 2 and 3. We send them to one side. Then x and y, we group those ones also. Now, after you've done that, the next thing you need to do is to multiply the coefficients. So you multiply 2 by 3. You multiply the numbers in there. So we know that 2 times 3 will give us 6. Then we have the x and the y. Then from there, you multiply the variables using the rules of indices. So if you watch the video on indices, you will see that if you multiply x by y, you are going to get xy. So our final answer is going to give us 6xy. Remember, 6xy is the same as 6 times x times y. In the first video, we said that we do not write multiplications and divisions in algebraic expressions. So usually 6 times x times y is written as 6xy. The rules for division also follows the same as the rules for multiplication. So let's take some examples on this and become conversant with it. So the question says that we should multiply or divide the following expressions. So where is multiplication, we are going to do that, and where is division, we are going to do that. So we begin with the first one. We have 4y times 2x. Just as we did in the previous slide, first we will group the coefficients and the variables. So in doing that, we are going to get 4 times 2 times y times x. Then the next step is that we have to multiply the coefficients. So we multiply the numbers. 2 times 4 times 2 will give us 8. So we do that. So we are going to get 8 times x times y. Now we've changed the position of x and y because we said in the first video that when there are variables in an algebraic expressions, the numbers must come first, then the letters will follow, or the variables will follow in alphabetical order. And we know that x comes before y, so you are going to get x times y. Now when we multiply that, we are going to get 8xy. So we multiply x and y using the laws of indices. When we do that, x times y is given as sy. So 8 times sy is given as 8sy. Let's take the next example. 12 times 12xy times 3by. So once again, the first thing we need to do is to group the coefficients and the variables. So in grouping the coefficients and the variables, 12xy times 3by will be equal to 12 times 3. Then the variables will come. So x times y times b. Now we can see from here that we have 12 times x, and the 12 was obtained from here. The 3 was also obtained. 12 times 3, sorry. The 12 was obtained from here, and the 3 was also obtained from here. Then we have x. There is only one x in this expression, so times x. We have y times y because we have y here and y here. Then there is only one b, so times b. So the next step is to multiply the coefficients or the numbers. So we have 12 times 3, and we know 12 times 3 will give us 36. Now remember, since there are variables or letters, we list them in alphabetical order. So b must come first, then x and y. Now when we are multiplying y by y, the laws of indices tells us that if you multiply y by y, we are going to get y squared. To understand this in details, please watch the videos on indices and you get that. So 3 times b times x times y squared. So we can see from here that if we are multiplying this, we are now going to get 36bx y squared. So y times y will give us y squared. B times x times y squared times 36. We are going to get 36bs y squared. In the first video, we said that when there are numbers and variables, the numbers will come first, then the variables will follow in alphabetical order. Let's take the third example. We have 3h squared times k squared times 3. So what we have to do here is that once again, we group the variables and the coefficients. The coefficients are 3 and 3. So we have 3 times 3, then times the variables are a squared and k squared. So from here, we multiply the coefficients. So 3 times 3 will give us 9. Now times h squared times k squared. So we are going to get 9h squared k squared. So if you follow the laws of indices, we will see that multiplying a squared by k squared will give us h squared k squared. We multiply that by 9 and we are getting 9h squared k squared. The fourth example, we have minus 3xy times 2y. So once again, we group the coefficients and the variables. So grouping the coefficients, we are going to get minus 2 times 2. The variables, we have x, there's only one x, then we have 2 of the y, so y times y. We've seen that if you multiply y by y, you are going to get y squared. So To begin with, we are going to multiply minus 3 by 2. Minus 3 times 2 give us minus 6. So times x times y squared. So minus 6 times x times y squared is giving us minus 6sy squared. Let's take an example on division. The division of algebraic expressions also follows the same step as that. So just as we grouped the coefficients and variables, in division we are going to do the same thing. But this time we are going to divide like terms. We are going to divide terms with the same letters or variables. So we are going to divide terms with the same letters or variables. So we can see in this question that we have coefficients 30 and minus 5. So we group that. Then we also group terms with the same letters. So we have x here, we have x here. So we group that. We have y here, we have y here. So we group that. So in grouping that, we are going to get this. So we are going to have 30 divided by minus 5. So the numbers have been grouped, or the coefficients have been grouped. Then times, we group the letters or variables with the same letters. So we have x here, we have x here. The x on the numerator side is s to the power minus 5. So we have s to the power minus 5 divided by x to the power you have s to the power 5 divided by x to the power 3. Then times y to the power 3 divided by y to the power 2. So you perform this operation using the laws of indices. We know that 30 divided by minus 5 will give us minus 6. From the laws of indices, x raised to the power 5 divided by x raised to the power 3 will give us x raised to the power 2. In the laws of indices, we said that when numbers are having the same basis, all that you need to do is to subtract the exponents. So if they have the same basis, you subtract the exponent. So since the base here is x and the base here is also x, what we have to do is to subtract the exponent. So you pick one of the bases, which is x, and you subtract the exponent. So we have 5 minus 3, and that is giving us 2. Then y exponent 3 divided by y exponent 2. So they also have the same basis. So you pick one of the bases, y. Then you subtract the exponents, 3 minus 2. Remember that 3 minus 2 is 1. Y exponent 1 is the same as y. So if you watch the video on indices, you are going to understand how these computations were done. So from here we have minus 6 times s squared times y. So minus 6 times s squared times y will give us minus 6 s squared y. Let's take another example on division. We have 64xy divided by 8y. So to make the division simpler, we write it in this form: 64sy over 8y. So just as we did for the example above, we first group the coefficients. So we have 64 divided by 8. You group that on one side. Now times x. The x is only on the numerator part. There is no denominator. So in natural sense, it's going to be x over 1, which is the same as x. Times, we group the y's. So we have y over y. Now let's proceed. We know that 64 divided by 8 will give us 8. We already have times x here. We know that y divided by y will give us 1. So we are going to have 8 times x times 1. Now 8 times x times 1 will give us 8x, because 8 times 1 is 8. So we are going to have 8 times x, which is 8x. So when dividing, group the variables and the coefficients, then divide the coefficients and use the laws of indices to divide the variables. Thank you so much for watching this video. See you in the next video, where we will learn how to multiply algebraic expressions that involve brackets. We are on the topic of algebraic expressions, and there is the fourth video on algebraic expressions. In the previous video, we learned how to multiply and divide algebraic expressions. In this video, we are going to learn how to multiply algebraic expressions that involve brackets. So let's learn how to remove brackets in algebraic expressions. Brackets are used to group terms. To remove the bracket or expand an expression, we use the distributive law. Now, what does the distributive law say? In the distributive law, we say that multiply each term in the bracket by the term outside the bracket. So, for example, if you have this expression A, if you have the expression A into bracket B plus C, to expand or remove this bracket, we use the distributive law, and the distributive law says that multiply each term in the bracket by the term outside the bracket. The term outside the bracket is A. The terms in the bracket are B and C. So use what is outside the bracket to multiply what is inside the bracket. Distribute it over it. So in this case, we are going to have A is going to multiply B. So we are going to have A times B. Then plus A is going to multiply C. So A times C. So that's all. This is what we are going to do here. We are going to use what is outside the bracket to multiply what is inside the bracket. Remember that when we do that, we will add the individual results. So we add what we get here and what we get here. That is why we have the addition sign here. Now, when you are multiplying, take note of the following signs. When you are using what is outside the bracket to multiply what is inside the bracket, take note of the following. If you multiply positive by positive, you are going to, if you multiply positive by negative, you are going to have a negative. So if you have positive 2, let's say plus 2, multiplying negative 1, you are going to get negative 2. If you multiply negative by positive, you are going to get negative. So for example, if you have negative 2, multiplying positive 1, you are going to get negative 2. If you multiply a positive by a positive, you are going to get a positive. So if you have 2 multiplying 2, you are going to get 4. So positive 2 plus times positive 2 will give us positive 4. But if you have a negative multiplying a negative, you are going to get a positive. So if you have negative 2 multiplying negative 2, you are going to get positive 4. Now let's take examples and learn more about how to do this. So we are told to expand and simplify the following. We have been given from 1 up to 7. So let's take them one after the other. So we take the first one, A plus 2. Now we can see from here that A plus 2 is in a bracket and there is nothing outside the bracket. As we've learned in previous videos, if there is nothing outside the bracket like this, it means that the coefficient of this is 1. 1 is outside the bracket. So we are going to use 1 to open this bracket. This is just for the preliminary stages. As we go on, we are going to take more detailed examples. So A plus 2 all into bracket is equal to 1 into bracket A plus 2. So now we have 1 outside the bracket. So we are going to use 1 to multiply through the bracket. We are going to distribute 1 over the terms in the bracket. So we are going to get 1 times A plus 1 times 2. So we continue. 1 times A will give us A plus 1 times 2 will give us 2. So we've now opened the bracket. So we can see that since 1 is multiplying what is the bracket, our final answer is going to be the same as what we had in the bracket. Now let's move a step further. This time we have 2 outside the bracket, and what is in the bracket is s plus 2. So we have 2, then bracket open, s plus 3. So we will do it the same as we did for the first instance. You will distribute what is outside the bracket over what is inside the bracket. So in this case, we are going to have 2 times x plus 2 times 3. So we will move on. 2 times x, we've learned from multiplications of algebraic expression that 2 times x is the same as 2x. Then 2 times 3 will give us 6. Now we can see from here that 2x and 6 are not like terms, so we cannot add them further. So we are going to end here. So 2 into bracket x plus 3 will give us 2x plus 6. I hope you can see the pattern in what we are doing. Let's take another example. Minus 3 into bracket 2x minus 4. So now we distribute minus 3 over what is inside the bracket. So we begin by, the first one is going to be minus 2 times 2x. That will be in one bracket. Then once again plus, remember the addition must always be there, plus what is outside the brackets here, so minus 3 times what is here, minus 4. So to begin with, we have minus 3 times the first term here, which is 2x. Then plus, you open another bracket, minus 3 times what is here, which is minus 4. So we have distributed what is outside the bracket over what is inside the bracket. Now let's continue. Remember, we said that when negative multiplies positive, it's negative. When we were doing multiplications of algebraic expression, we said that if you multiply minus 3 by 2, so you are going to have minus 3 times 2x. What we said was that first group the coefficients, so you are going to get minus 3 times 2 times x. Then you multiply minus 3 and minus 2 and 2, then you multiply the result by x. So we can see that minus 3 times 2x will give us minus 6x. Now we said that if you multiply a negative by a negative, you are going to get positive. So minus 3 times minus 4 is giving us positive 12. So minus 3 times minus 4 is giving us positive 12. So we are going to get minus 6 plus 12. Let's take another example. We have 10a plus, into bracket open, a plus 2. We have seen that whenever you have something like this and there is no number outside the bracket, what it means is that the coefficient is 1. So we have 1 here. Now we first deal with what is in the bracket. So 10 is not in a bracket, so we don't concentrate on that for now. But we've seen that what is outside the bracket is 1. And whenever you have 1 multiplying something, is the same thing. So 1 times a plus 2 will give us a plus 2. Because you are going to get 1 times a, which is a, plus 1 times 2, which is 2. Then from here, you group like terms. We can see that 10a and a are like terms. So we group the like terms and we add them. So if you add 10a to a, you are going to get 11a. Remember that a is the same as 1a. And when we were doing additions of algebraic expression, we said that you add the coefficients. So we add 10 to 1 and we are getting 11. So we have 11a plus 2. 11a and 2 are not like terms, so we cannot add any further. Let's take another example. This time we have 2 brackets here. So we first deal with the first bracket, then we go to the second bracket. So in dealing with the first bracket, we do it the same as we have been doing. Distribute what is inside the bracket over distribute what is outside the bracket over what is inside the bracket. So we are going to get 2 times 4 times 2t. So we are going to have 4 times 2t, as we can see here. So 4 times 2t, as we can see here. 4 times 2t plus 4 times 1, then we have here. Then plus, remember that we always bring the positive sign. So plus, now you come to what is in the second bracket. What is outside the bracket is minus 3. So minus 3 will multiply what is the first term in the bracket, so minus 3 times t. So we are going to get 4 times 2t in one bracket plus 4 times 1 in one bracket, then plus minus 3 times t in one bracket. Then you bring the plus again and you open another bracket, minus 3 times minus 2. So you distribute what is outside the bracket over what is inside the bracket. Now whenever you close a bracket, make sure that the next sign is addition. So in the first instance, we have 4 times 2t in the first bracket, then plus 4 times what is inside the bracket here is plus 1, so plus 1. Then you bring your plus sign again, minus 3 times t, so minus 3 times t in one bracket, then plus minus 3 times minus 2 in another bracket. So we move on. We have seen from multiplication of algebraic expressions that 4 times 2t is going to give us 8t. 4 times 1 will give us 4. Now we come here. Minus 3 times t is going to give us minus 3t. But we have plus here and we have minus in the bracket. So it's going to be like this. So we already have a positive sign here. Then what is in the bracket is giving us minus 3t. Now whenever you have plus and minus meeting like this, everything changes to minus. So that's why we have minus 3t here. Then we have plus. Remember, minus 3 times minus 2 is giving us positive 6. So from here, we group like terms. The like terms here are 8t and minus 3t. They go to one side. Then 4 plus 6 also goes to another side. We subtract this. We learned from addition and subtraction of algebraic expressions that when you are subtracting, we subtract the coefficients. So we are going to get 8 minus 3, which is going to give us 5. So we have 5t. Then 4 plus 6, which is going to give us 10. So we have 5t plus 10. Now let's take another example. Minus bracket open 15m plus n, then minus another bracket opens m plus n. So let's continue. Once again, whenever you have this and there is no sign outside the bracket, what it means is that the sign there is 1. So here we can say that the number that when there is a sign there but there is no number there, then it means that the number there is 1. So the number here is going to be 1 and the number here is also going to be 1. So we are going to use minus 1. We are going to distribute minus 1 over what is in the bracket. So once again, we start by opening the first bracket. So we are going to get minus 1 times 15m in one bracket. Now we've closed this bracket, so we bring our addition sign. Then we move to the next one. Minus 1 times what is in the bracket here, which is n plus n. So we are going to get minus 1 times n. Then we move on to the next section. Remember, since we've closed this bracket, we bring another addition sign. The next bracket, we have minus 1 times m. So that bracket will come. Then since we've closed this bracket, we bring another addition sign. Then we go on to the next one, minus 1 times n. So minus 1 times n, then we close the bracket. Now let's deal with what is in the bracket. Minus 1 times 15m is going to give us minus 15n. Now minus 1 times n is going to give us minus n. So we have plus here and we have minus here. Once, as I said here, whenever you have plus and minus meeting like that, the whole thing changes to minus. So you are going to get minus n. Then when you come here, what is in the bracket is giving us minus 1 times n. Minus 1 times m is going to give us minus m. Once again, we have plus and minus meeting, so it changes to minus. Then when you come to the last portion, what's in the bracket is giving us minus 1 times n. We know that minus 1 times n is giving us minus n. Once again, we have plus and minus meeting, so everything changes to minus. From here, we group like terms. So in grouping like terms, we are going to have the m's at one side and the n's at one side. If you group the m's, you are going to get minus 15m minus m minus n minus n. So all these variables with no coefficients attached to them, what it means is that they are all 1 and 1 in front of them. So minus 15 minus 1 is going to give us minus 16. So you have minus 16m. Then minus 1 minus 1 is going to give us minus 2. So minus 2n. Let's take the last example, 7. A bracket open, b minus c, then bracket close, plus d bracket open, b minus c bracket closed. So once again, we distribute what is outside the bracket over what is inside the bracket. So we start. We are going to have a times b as seen here. So a times b in the first bracket. Then since you've closed this bracket, you bring your addition sign to plus. We are going to open another bracket. A times what is inside here, which is minus c. So a times minus c. Then you close that bracket. You bring your addition sign since you've closed a bracket. Then you open another one again. We are doing it for this side. D times b is going to be d times b here. Then since we've closed the bracket here, we bring addition sign and we open another bracket. D times minus c. So d times minus c will be here. Now we've learned from multiplication of algebraic expressions that a times b is going to give us ab. Now a times minus c is going to give us minus ac. So from here we can see that we have plus here, and what is in the bracket is giving us minus. We have learned that when plus and minus meet in that way, it changes to minus. So minus ac. Then plus d times b, that's going to give us bd. Remember we said that if there are variables, the variables are listed in alphabetical order. So it is bd, not db. Then we have d times c, d times minus c to give us minus cd, not dc. So we can see from here that there are no like terms here. So we can't add any further. Thank you so much for watching this video. Pay attention to the pattern or the ways that the questions were solved, and pick more examples on algebraic expressions that contain fractions, that contain brackets. See you in the next video where we will learn how to multiply two binomials. Bye bye. The topic we are treating today is algebraic expressions, and this is the 5th video on the topic. In the previous video, we learned how to expand and remove brackets in algebraic expressions. In this video, we are going to learn how to multiply two binomials. So, multiplication of two binomials. What is a binomial? A binomial is an expression of two terms. So, example, x plus 2, x plus 1. So we can see from this example here that in the first bracket we have x plus 1. We know that x is a term and 2 is also a term. So we have two terms. Then in this example we have x plus 1. So x is a term and 1 is also a term. So here you have two terms. So an expression of two terms. So in this case x plus 2, or in this case s plus 1, these expressions are called binomials. So s plus 2 is a binomial and x plus 1 is a binomial, an expression of two terms. Now to multiply two binomials, we use the distributive property, just as we did in expanding or removing of brackets. We use the distributive property in expanding two binomials. Each term in one bracket multiplies each term in the other bracket. Now, what does it mean? What it means is that when you come in, we have two terms here. So we use the first term to multiply what is in the second term. We use the first term in the first bracket to multiply everything in the second term, then use the second term in the first bracket to multiply everything in the second bracket. So use the first term, in this case x, to multiply everything in the second bracket. Then use the second term here, in this case 2, to multiply everything in the second bracket. We are going to take examples to see how to do that. So expand and simplify the following. We are going to do 1 up to 5. So let's begin with the first one. The first one says that we have x plus 2 into one bracket, then x plus 4 into another bracket. So in this case, we have x plus 2 here multiplying x plus 4. Now, in order to expand this is what you do. You use the distributive property. So we take x and we distribute it over x plus 4. Then we take 2 and we distribute it over x plus 4. So this is how it's going to be like. Use what is in the first bracket, the first term, which is x, and multiply it by the second bracket, which is x plus 4. Then take what is in the second bracket, in this case x plus 2, and multiply it by what is in the second bracket, in this case x plus 4. So you can see from here that this is an example of what we did in the previous video. So from here you go ahead, open the brackets, and you simplify. So if you are opening this bracket, we know that the first one is we are going to have x times x in one bracket, then plus x times 4 in another bracket, plus 2 times x in one bracket, plus 2 times 4 in another bracket. We've seen from multiplication of algebraic expressions that x times x is going to give us x squared, x times 4 is going to give us 4x, 2 times x is going to give us 2x, and 2 times 4 is going to give us 8. So we add like terms. We can see from here that the only like terms here are 4x and 2x. So we add them. So we have x squared plus 4x plus 2x is going to give us 6x, then plus 8. If you want to understand how 4x plus 2x is giving us 6, watch the second video on additions and subtractions of algebraic expressions. Now move on to the next example. We have 2x plus y in one bracket, then 2x minus y in another bracket. So just as we did in this case, we take what is in the first bracket, the first term here, we distribute it over everything here. Then we take the second term and distribute it over everything here. So the first term is 2x. So 2x times everything in the second bracket, which is 2x minus y. We take the second term plus y times everything in the second bracket, which is 2x minus y. So we are multiplying. You are going to have 2x times 2x in one bracket, then plus, once again I said after you've closed the bracket here, the next sign must be a positive sign. So plus, use what is outside the bracket here to multiply what is inside the bracket. So 2x times, the term here is minus y, so you're going to get 2x times minus y, then plus y times 2x, so y times 2x. So this must not be there. Okay, so y times 2x, so y is going to multiply 2x. Then we move on, we are going to get y plus y times minus y, so plus y times minus y, as we have here. Then let's continue. We know that 2x times 2x is going to give us 4x squared. Once again, if you watch the video on multiplications of algebraic expressions, you understand why 2x times 2x is going to give us 4x squared. Then move on to the next bracket. The next bracket is going to give us 2x times minus y. We know that that's going to give us minus 2xy. Then the next one, we have y times 2x, and we know that that's going to give us plus 2x. Then y times minus y is going to give us minus y squared. So we can see from here that we have minus 2x and we have plus 2x. So minus 2x and plus 2x are going to cancel each other out. So finally we are going to get 4x squared minus y squared. Let's take the third example. We have a minus b, a minus 5 in one bracket, then a minus 7 in another bracket. So as usual, we distribute what is in the first bracket over what is in the second bracket. So we are going to have a, which is the first term here, times everything in the second bracket, then minus 5, which is the second term here, times everything in the second bracket. So we are opening the brackets. So we are going to get a times a in the first bracket. Then since this bracket is closed, you bring your addition sign. So plus a times minus 7. Then you bring your addition sign again. Then you come to this side here. What is outside the bracket is minus 5. So minus 5 times a in the bracket here. Then plus what is outside here is minus 7. So minus 7 times minus 7 in another bracket. Then let's continue. We know that a times a will give us a squared. A times minus 7 will give us minus 7a. Minus 5 times a is going to give us minus 5a. And minus 5 times minus 7 is going to give us 35. So from here, we proceed by simplifying further. You can see that the only like terms here are minus 7a and minus 5a. And we know that minus 7a minus 5a is going to give us minus 12a. So we are going to have a squared minus 12a plus 35. If you watch the video on additions and subtractions of algebraic expressions, you understand why minus 7a and minus 5a is giving us minus 12a. Let's take the next example. We have x minus 2y in one bracket, then 3x plus 4y in another bracket. So as usual, we distribute what is in the first bracket over what is in the second bracket. So we take the first term, which is x, is going to multiply everything in the second bracket. Then you take the second term, which is minus 2y, and is going to multiply everything in the second bracket. So we begin the multiplication. We have x times 3y in one bracket, then plus x times 4y in another bracket. Then you bring our addition sign. We come to this side here. We have minus 2y times 3x in another bracket, then plus again, what is outside the bracket here is minus 2y. The last term here is 4y. So minus 2y times 4y. From multiplications of algebraic expressions, we have come to see that x times 3x is going to give us 3x squared. Then when we come here, we have x times 4y giving us 4xy minus y times minus 2y times 3x is going to give us minus 6xy. Then minus 2y times 4y is going to give us minus 8y squared. So the only like terms we have here are 4xy and minus 6xy. From additions and subtractions of algebraic expressions, we've come to see that minus 4xy and minus 6xy is going to give us minus 2xy. So finally, we are going to have 3x squared minus 2xy minus 8y squared. Now, let's take the last example. X minus 2 all squared. Now, if you watch the video on indices, you came to see that if you have a squared is the same as a times a. So if you are having minus s minus 2 all squared, s minus 2 all squared is the same as s minus 2 in one bracket, then s minus 2 in another bracket. So just as a squared is going to give us a times a, s minus 2 all squared is going to give us s minus 2 in one bracket, then s minus 2 in another bracket. So you can see from here that we have two binomials. So we do the multiplication as we have been doing all along. We distribute everything in the first bracket over everything in the second bracket. So x times what is in the second bracket, which is s minus 2. Then the next term here is minus 2, so minus 2 times everything in the second bracket, which is s minus 2. So you know that in this case you are going to have s times x in one bracket, then plus, you open another bracket, x times minus 2 in another bracket, then plus, you open another bracket. What is outside this bracket here is minus 2, so minus 2 times x in one bracket, then plus, you open another bracket, lastly minus 2 times minus 2. We know that s times x is given as s squared. Now x times minus 2 will give us minus 2. Minus 2 times s times minus 2 is given as minus 2x. Minus 2 times x is given as minus 2x. Minus 2 times minus 2 is given as positive 4. The like terms we have here are minus 2x and minus 2x. We know that minus 2x and minus 2x is given as minus 4x. So finally, our expression is going to be s squared minus 4x plus 4. Study the pattern in this video and solve more examples on multiplying two binomials. Thank you so much for watching this video. See you in the next video where we will learn how to factorize algebraic expressions. Bye-bye. The topic we are treating today is algebraic expressions, and this is the 6th video on the topic. In the previous video, we learned how to multiply two binomials. In this video, we are going to learn how to factorize algebraic expressions. In expansions, we open brackets by using the distributive rule and simplifying afterwards. So we saw in the previous video that when you have two binomials and you are multiplying them, you use the distributive rule by distributing what is in the first term over what is in the second term. Then after the multiplication, you simplify. In factorization, we are going to do the exact opposite of that. We are now going to put the expressions given us in brackets so that we can make them smaller. And the way we are going to do that is by taking the common factors out, then we put what is left in the brackets. Let's take some examples and see what you're talking about. So you are being told to factorize the following. You have been given from question 1 up to question 6. So let's begin by solving question 1. Now the main thing that you have to take note of when it comes to factorization is that we use brackets a lot. So you are being told to factorize 2x minus 12. The first step that you have to do is to put the expression in the bracket. Now after you've put the expression in the bracket, the next thing that you have to do is to take the common factor out. Now we can see from here that we have 2x minus 12 here. Now x is only attached to 2. There is no x attached to 12. So that is not a common factor. So we look at the coefficients. The coefficient of x is 2. Now the constant term here is minus 12. When that happens, what you have to look out for are numbers that can divide both 2 and 12 without remainders. We know that numbers that can divide both 2 and 12 without remainders are 1 and 2 itself. So we have 1 and 2 as numbers that can divide both 2 and 12 without remainders. So you pick the highest one, which is 2. So in this case, 2 becomes our common factor. So we have 2 as our common factor. As soon as you have the common factor, you write the common factor outside the bracket. Now we deal with the terms in the bracket. We know that what used to be here was 2x. We have 2 as the common factor and we've written it outside the bracket. If you want to get the first term in the bracket, divide what used to be there by the common factor. So in this case, we are going to divide 2x by the common factor, which is 2. We know that if you divide 2x by 2, 2 is going to cancel 2 and that will give us x. Now, the next step is to go to what you get for the second term in the bracket. Now we know that what used to be there was 12, so 1 and 2. Now the common factor is now 2, so we divide that by 2. And you know that 12 divided by 2 is going to give us 6. So 12 divided by 2 will be given us 6. Sorry. Okay. So 12 divided by 2 will be given us 6. So that is how come we are having 2 into bracket x minus 6. Now we can see from here that if you expand this, you are going to get 2 times x to give us 2x, then 2 times minus 6 to give us minus 12. So after you factorize, if you expand it, you should get the expression that you began with in the first place. Let's move on to the second one. X squared y squared minus x. So once again, you put the whole thing in a bracket, then you look for a common factor. We can see from here that we have x squared y squared here, and we have x here. They only have x in common, so in this case the common factor here is x, so you pick the common factor x outside. So you can see from here that this is x squared and this is x. You pick the least one here, so you pick x, not x squared. You pick x as the common factor. So after you've picked x outside, now what is next? The next thing that you have to do is to find a way of determining what is in the bracket. So the first term here, we know that what used to be here was x squared y squared. Now x is a common factor, so we are going to divide x squared y squared by x. You know that if you divide x squared y squared by x, you are going to get xy squared. Then you bring your subtraction sign. Now what used to be here was x. This time the common factor is x, so you divide x by x and you are going to get 1. So you get x into bracket xy squared minus 1. Now if you try multiplying it back, you will see that x times xy squared will give us x squared y squared. Then x times minus 1 will give us minus x, as we have in the question. Let's look at the next one. 5ax plus 2y, 25ay. So we look for common factors. First, we begin with the coefficients. We have 5 and 25. So from here straight away, we can see that the common factor is 5. Since 5 can divide itself 1 and divide 25, 5. Now, the next factor that we look for is a, because we have a here and we have another a here. So in this case, we have 2 factors. We have 5 and a. So you bring those factors outside the bracket. So you first begin by putting them in the bracket, then you bring the factors outside the bracket. So we have 5a outside the bracket. You know that what used to be here was 5ax. This time the common factor is 5a. So if you want the first term here, divide 5ax by 5a. You know that 5ax divided by 5a is going to give us x. Then you move on to the next one. We have 25ay. That was what used to be there. This time the common factor is 5a. So we divide 25ay by 5a. You know that when that happens, 5 will cancel 25 5 times. A will cancel a, so that we get 5y. Now let's try multiplying this back and see. You can see that 5a times x will give us 5ax, plus 5 times 5 will give us 25. A times y will give us ay, so you get 25ay. So whenever you do the factorization, after that, if you try expanding it, you should get the question that was given to you. Let's move on. This time we have 4 terms here. Now whenever you have more than 2 terms, group 2 terms that have something in common. So group 2 terms that have something in common. So if you take this term here, 3x squared and 2xy, we can see that they have x in common, so you can group them. You move on to the next one, minus 12xz minus 8yz. We can see that they also have z in common. And here there is a number that can divide both 12 and 8, so that they also have that in common, so we can group them. So we group them by putting a bracket around them. So you put a bracket around the first 2, then you put a bracket around these ones also. Okay, so let's proceed. When you come here, we now have to factorize. So we are going to factorize this. You know that from here we have 3 and 2. The only number that can divide both 3 and 2 without remainders are 1. So we move on to the variables. We have x here and we have x squared here, we have x here. So it means that the common factor is now x. So we pick the least one, which is x. We pick that one outside the bracket. So we bring x outside the bracket. Now what used to be here was 3x squared. So if you want the first term in the bracket, you divide 3x squared by the common factor, which is x. So you divide 3x squared by x and you are going to get 3x. Now you come to this side. What used to be here was 2xy. The common factor is now x. So you have taken the x away from it. If you take the x away from it, you are going to get 2y. So you can see from here that if you multiply 3 by 3x, you are getting 3x squared. If you multiply 2xy by x, if you multiply 2y by x, you are getting 2xy. So we have this back. Now let's come to this side. When we come here, we can see that there is 12 here and there is 8 here. So let's first begin with the coefficients. Now numbers that can divide both 12 and 8 without remainders will be 1, 2 and 4. They are the numbers that can divide both 12 and 8 without remainders. Now when you have that, you pick the highest one, which is 4. So 4 will be a common factor, because when 4 divide 12, you are going to get 3, and when 4 divide 8, you are going to get 2. So you see that from 3 and 2, you can't simplify them any further. That is why we are picking 12. If you pick 2, when 2 divide 12, you are going to get 6. 2 divide 8, you get 4. You can see from there that 6 and 4, you can simplify them further. But when you pick 12, you can't simplify further. That is why when you pick 4, you can't simplify further. That's why we are picking 4. So for the coefficients, the common factor there will be 4. Now, we look at for the coefficient, the common factor there will be 4. We look at the variables. For the variables, we have x here and we also have x here. Now, since you have x here and x here, since you have z here and z here, z is your common factor. So you pick that one in addition to the 4. So you write that outside the bracket. Now we know that what used to be here was 12xz. Now the common factor is now 4z. So if you divide 12xz by 4z, you can see that z will cancel z, 4 will cancel 12, giving us 3. So we have 3x. So here used to be 12xz, but we have taken 4z outside. So what will be left is now 3x. Then we move on to the next part. Now we can see from here that the sign here was negative, but when it came here, it has changed. When you come here, it has changed to positive. This is what it means. Whenever you have a negative sign outside the bracket and you bring the common factors out, the sign in the bracket, if it's positive, it changes to negative, and if it's negative, it changes to positive. So here we have a negative sign outside the bracket. We brought the common factors, which are 4 and z, outside the bracket. So the sign in the bracket, the sign between the two terms in the bracket, which was negative, is now positive. If that sign was positive, it would have changed to a negative sign. We are going to pick more examples so you get conversant with this. Now we can see from here that we have 3x plus 2y in this bracket. We also have 3x plus 2y also in this bracket. They are common there. So when that happens, you are going to pick one of them. Then we pick the common factors that we had also into another bracket. So you put one of the two common ones, which is 3x plus 2y, 3x plus 2y. You pick one of them, then you pick the common factors also. So here, now this one is z, this is not y. So that was a mistake. So here is z. So you are going to get z here. Okay. So we can see from here that we are having 3x plus 2y in one bracket, then you pick x minus 4z in another bracket. Let's take another example. AB minus BC plus AD minus DC. So here what you do is that you group two terms that have something in common. So when you come here, we can see clearly from here that AB and BC have B in common. AD and DC also have D in common, so you can group them. So you group them like that. We have AB. Okay, so from here what I did was that I brought AB, I added AD to AB, then I brought BC and DC together. So nothing changed. I just changed the positions. You can also do it the other way around and you must get the same answer. So AB and AD in one bracket, then BC and DC in also another bracket. So you put the brackets around it. Now from here we can see that AB and AD, the common factor there is A. So we bring A outside the bracket. Then what is inside the bracket? Here used to be AB. You have taken A outside, so it will be left with B. Here used to be AD. You have taken A outside, so it will be left with D. Now when you come here, you have BC and DC. You know that the common factor there will be C. So we bring C. Now we can see from here that here used to be BC and we've brought C outside the bracket, so what will be left will be B. Now once again, the sign in front of the bracket is a negative sign. We say that when that happens, the sign in the bracket will change. If it's negative, it will become positive. If it's positive, it becomes negative. In this case, it was negative, so it will become a positive sign here, so plus AD. Now you can see that B plus D and B plus D are in the bracket. They are the same, so you pick one of them, then you pick the common factors, which is A and minus C in another bracket. So you have A minus C in one bracket, B plus D in another bracket. Let's pick the next example. X squared minus 2xy plus 3xu minus 6yu. So we pick two terms that have something in common. So this x squared and 2x have x in common. 3xu minus 6yu will have u and 3 in common. So you put them in brackets. So we put this in bracket here. X squared minus 2xy plus 3xu minus 6yu. So we deal with the first bracket. The common factor here will be x. So we bring x outside. Here used to be x squared. So x squared, we've taken one of the x's outside. So you are going to, what is in the bracket will now be x. Then minus, here used to be 2xy. We've brought the x outside as a common factor. So what will be left will be 2y. Then plus, now when you come here, we can see that 3 can divide itself 1 and can divide 6 2. So 3 will be a common factor. So 3 will come outside. Now you have u here and you have another u here. So 3u will be the common factors. Now what used to be here was 3xu. And we have taken 3u outside. So what will be left will be x. Now here used to be 6yu. We have taken 3u outside. So the 6 will now reduce to 2, such that when we multiply 3 by 2, you get 6. We have taken the u outside. Now the y will be left. So you can see clearly from here that what is in the brackets are also the same. So you have x minus 2y in one bracket, x minus 2y in another bracket. So you pick one of them, then you pick the factors that we used in factorize. So x plus 3u. Now you can see that the sign in here was negative. We did not change it because the sign in front here was positive. If the sign in front of the bracket here is positive, you don't change it. But if the sign in front of the bracket is negative, the sign in the bracket separating the two terms will change to the other sign. So if it's positive, it will be negative. If it's negative, it becomes positive. Here, the sign in front of the bracket was positive, so the sign between the two terms in the bracket must be the same. So we are going to have 3 plus 3u. So x plus 3u, sorry, in one bracket. Then you pick one of these, x minus y, x minus 2y, x minus 2y. You pick one of them. So 3x plus 3u in one bracket, x minus 2y in another bracket. Thank you so much for watching this video on factorization of algebraic expressions. Pick more examples and follow the pattern that was used in solving the questions in this video. See you in the next video, where we will tackle another important thing in algebraic expression, difference of two squares. Bye bye. We are on the topic algebraic expressions. In the previous video, we learned how to factorize algebraic expressions. In this video, we are going to learn how to use the principle of difference of two squares to factorize an algebraic expression. So let's begin by learning what difference of two squares are. Expressions of the form s squared minus y squared are called difference of two squares. So whenever you have an expression where the first term is a squared and the second term is also a squared, then we have the first term minus the second term. We say that we have a difference of two squares. So s squared minus y squared is just an example that was given. Another example of difference of two squares can be a squared minus b squared. That is also difference of two squared. You can also have 4 squared minus 2 squared. That is also another example of difference of two squares. Now, if you have difference of two squares, how do we expand it? If you have difference of two squares, how do you expand it? S squared minus y squared is a difference of two squared, and it's expanded as s plus y in one bracket, then s minus y in another bracket. So all that this means is that whenever you have s squared minus y squared, the expansion is s plus y in one bracket, s minus y in one bracket. That is the first term plus the second term in one bracket, then the first term minus the second term in another bracket. We are going to pick some examples using this principle and see how it's used. But there are some things that you must take note of. Remember that both the first and second terms must be a perfect square. That is, it must be that term squared. And the sign between them must be the negative sign. So it must be the first term squared, the second term squared, and the sign between them must be negative. So if you have s squared plus y squared, it is not difference of two squares. For this to be difference of two squares, the sign here must be negative, not positive. Now let's pick some examples and see. Using difference of two squares, factorize the following. So we have been given I, and I. Then the second question says that find K if 3K plus 13 squared is equal to 16 squared, using difference of two squares. So let's begin with the first one. We have 4s squared minus y squared. Now we can see from here that this in itself is not difference of two squares, because we learned from the previous slide that if you want difference of two squares, the first term must be square and the second term must also be a square. Then this must be negative. So the negative is there, the second term is a square. But the first term is 4s squared. The 4 here is preventing this from becoming a square. Now, to take care of that, we know that when we were learning indices, we came to see that 4 is the same as 2 squared. So 4s squared can also be written as 2 squared s squared. Then we have minus y squared. We have seen from indices that 2 squared s squared can also be written as 2x brackets all squared minus y squared. So we know from here that 4 has now been changed to 2 squared. Then we already have our s squared. We know from indices that 2 squared s squared can be written as 2x into brackets squared minus y squared. So we can now see that this is now difference of two squares, because right now 2s is our first term and y is our second term. So in this case, x has now been 2x and y is y. Remember, we said the principle of difference of two squares is that if you have s squared minus y squared is the same as the first term, which is x, plus the second term, which is y, then you open another bracket, the first term, which is x, minus the second term, which is y. So you see that if you are comparing this here, 2x is now x. We have the square here, so the square is there. The minus here, so minus is also there. Then y squared, so we have y also being y. So if you want to expand this, it's going to be the first term, which is 2x, minus the second term, which is y, in one bracket, just as we have here. We also have that here. Then the first term, which is 2x, plus the second term, which is y, in another bracket. So just as we have here, we also have that also there. So if you want to expand difference of two squares, make sure that you have the first term as a square, the second term as a square. Then it's written as the first term plus the second term in one bracket, the first term minus the second term in another bracket. You can change the positions and it doesn't matter. Remember when we were learning real numbers that we said that multiplication of real numbers are commutative. So you can change the position and it doesn't matter. Let's take the next question. 36p squared minus 49q squared, and we are supposed to use the principles of two squares. We know that 36p squared minus 49p squared, like this, we cannot use the principle straight away like this, so something has to be done. We have come to see that 36 can also be written as 6 squared, because 6 squared will give us 6 times 6, and 6 times 6 is 36. 49 can also be written as 7 squared. 7 times 7 will give us 7 squared, and know that 7 times 7 is 49. Now 6 squared p squared can be written as 6p all squared. 7 squared q squared can be written as 7q all squared. So you can see clearly from here that this is the first term, 6p. This is the second term, 6p. 7q. 6p is a squared, 7q is a squared, and we have minus here. So this qualifies as difference of two squares. You know that to expand this, what you do is that the first term, which is 6p, minus the second term, 7q, in one bracket. Then you open another bracket. The first term, which is 6p, plus the second term, which is 7q, in another bracket. Let's take another example. 2a squared minus 8b squared. Now we are supposed to use the principles of two squares to factorize this. We can see that this given to us straight away is not difference of two squares, so we need to do something about it. Now what do we do? If we factorize 2 out here, from the previous video we came to see that in this case, if you factorize 2 out, here used to be 2a squared, and you have factorized 2 out, so you have a squared, minus here used to be 8b squared. We factorized 2 out, so you need, here will be 4b squared. Remember, we've taken 2 from the 8, so yeah, we must get 4, so that 2 times 4 will give us 8. Here used to be 8, we factorized 2 out, so what will be left here is 4, because 8 divided by 2 give us 4. So we have a squared minus 4b squared. Now we can work what is in the brackets in such a way that we have a difference of two squares. So let's continue. We have seen that 4 can also be written as 2 squared. So in this case, 2 into bracket a squared minus 2 squared b squared can be written as 2b all squared. So if you look at it, we now have a squared minus 2b all squared. Remember, the second term here is now 2b. The first term is a. The first term, which is a, is a squared. The second term, which is 2b, is also a squared. They are being separated by a negative sign, so we have difference of two squares here. So in this case, if you are expanding, we know that you first bring your square bracket, because you have a bracket in a bracket, so the outside bracket must be square brackets. So first bring your square brackets. We know that if you are writing for difference of two squares in this case, you are going to have the first term minus the second term in one bracket, so a minus 2b in one bracket. Then in the second bracket, you are going to have the first term plus the second term, so a plus 2b in another bracket. Remember, they are all being multiplied by 2, which is outside the bracket. Let's take the final example. We are supposed to find q if 3q plus 13 squared is equal to 16 squared. Now from here we can see that we have to group like terms. So we group like terms, we group the numbers, the terms with numbers at one side, then we group the terms with variables at another side. So we can see that we have 16 squared here, we have 13 squared here. This 3 has a kill attached to it, so we are going to bring the 13 to this side. 13 is positive here, so when it crosses the equal sign to this side, it's going to be negative. So we are going to have 3q is equal to 16 squared minus 13 squared. Now you can see from the right hand side that 16 squared minus 13 squared is difference of two squares. 16 is the first term, it's a square. 13 is the second term, it's also a squared. It's being separated, they are being separated by a negative sign. So 16 squared minus 13 squared qualifies as difference of two squares. We know that to write 16 squared minus 13 squared using the principles of difference of two squares, if you are expanding it, you are going to have 16 minus 13 in one bracket, then 16 plus 13 in another bracket. So the first term minus the second term in one bracket, then the first term plus the second term in another bracket. So you are going to get 3q is going to be 16 minus 13 will give us 3. 16 plus 13 will give us 29. Now we have 3 in this bracket, 29 in this bracket, so they are going to multiply. So you are going to have 3 times 29. So 3q is going to be 3 times 29. Sorry, 3 times 29 will give us 87. Now to make q the subject, we divide both sides by 3. So we divide 3q by 3. We divide 87 by 3. 3q divided by 3 will give us q. 87 divided by 3 will give us 29. So you can see from here that we have used the principles of difference of two squares and we have been able to find q as 29. Thank you so much for watching this video. Take more examples on difference of two squares and use the principle as we used in this video. See you in the next video where we will learn how to factorize quadratic trinomials. Bye bye. The topic we are treating today is algebraic expressions. In the previous video, we learned how to use the principle of difference of two squares to factorize an algebraic expression. In this video, we are going to learn how to factorize quadratic trinomials. So let's begin by learning what a quadratic trinomial is. A trinomial is an expression containing two terms. So in the previous video, we saw that if an expression contains two terms, it's called a binomial. So if an expression contains three terms, it's called a trinomial. Now, a quadratic trinomial is a trinomial that has a quadratic term. The quadratic term in this example here is the squared term. So whenever an expression contains a square term, that expression is a quadratic expression. So you can see from this example as squared plus bs plus c that it contains a square term. You have s squared here. So this is an example of a quadratic expression. Now since it contains three terms, it becomes a quadratic trinomial. That is why one of the conditions that this expression has to satisfy is that a must not be equal to 0. Because if a is 0, we are going to get 0 times s squared, which is going to nullify the square term. Then this expression is no longer a quadratic trinomial. So we are going to learn how to factorize an expression like this in this video. So to factorize a quadratic expression or a quadratic trinomial, the first thing that you have to do is to multiply the coefficient of s squared by c, or to multiply a by c. So that's the first thing that you do. Then we are going to find two numbers that when you multiply, you are going to get a and c, or ac, a times c, when you multiply. But when you add, you are going to get b. After you've done that, the next thing you need to do is to replace b with those two numbers and you factorize the expression that you obtain afterwards. Now how do we do this? Let's take some examples and find out. So we are being told to factorize the following. We have been given from question 1 up to question 7. We are going to learn how to do that. Let's take the first question. S squared plus 7x plus 12. So we can see clearly from here that the coefficient of x squared is 1, and since it's 1, we are not writing it. So in this case, 1 will become our a, 7 will be our b, and 12 will be our c. The first thing that we need to do is to multiply a by c. So to multiply 1 by 12, we know that 1 times 12 is going to give us 12. Now we look for two numbers that when you multiply you will get 12, but when you add you are going to get b, which is 7. Usually we get those two numbers from the product of a and c. The product of a and c is 12, so it means that you are going to get those two numbers from the factors of 12. Usually get to those two numbers from the factors of the product of a and c. The product of a and c is 12 in this case, so you are going to get those two numbers from the factors of 12. We know that the factors of 12 are 1, 2, 3, 4, 6, and 12. Now when you look through the factors of 12, you can see that if we pick 3 and 4, when you add 3 to 4 you are getting b. When you multiply 3 by 4 you are getting 12. So the two numbers we are looking for are 3 and 4. So you pick those two numbers. Then the next step is that you replace 7, or you replace b with those two numbers. So you replace b with 3 and 4. So instead of writing 7x, you are going to have 3x plus 4x. You can see from here that we've changed nothing because x squared is here, x squared. 3x plus 4x is 7x. So we have just replaced 7x with those two numbers, 3 and 4. Then plus 12, we have that here. So from here you proceed to factorize as we were doing when we learned factorization of algebraic expressions. So you put the brackets around them. Here you factorize x out since x is the common factor. So we factorize x out here. So you are going to have x into bracket x plus 3 plus, we know that when you come here you divide 4 by 12, you are going to get 3. So we factorize 4 out, you are going to have s plus 3. Now we can see that we have s plus 3 in this bracket, s plus 3 in that bracket. So you are going to pick one of them, then you pick the factors outside the bracket, so x and plus 4. So you are going to have s plus 4 in one bracket, then s plus 3. So you pick one of them, s plus 3. Let's take the next example. 7y squared minus 3x minus 10. So we can see from here also that 7 will be our a, minus 3 will be our b, and minus 10 will be our c. So the first step that you have to do is to multiply a by c. A in this case is 7, c in this case is minus 10. So you are going to have 7 times minus 10. You know that 7 times minus 10 is going to give us minus 70. Now how do we proceed from here? We are looking at we are looking for two numbers that when you multiply you are going to get minus 70. When you add you are going to get minus 3. So you usually get those two numbers. In this case you are going to get those two numbers from the factors of 70. Remember I said that those two numbers you will get them from the factors of the product of a and c. In this case the product of a and c is minus 70, so you have to look at the factors of 70. We know that the factors of 70 are 1, 2, 5. Sorry, so you are going to get 1, 2, 5, 7, 10, 14, 35, and 70. Now these are the factors of 70. You can watch the video on sets and you know how to find the factors of a number. So these are the factors of 70. Now when we look through this, We are looking for two numbers that when you multiply, you are going to get minus 70. When you add, you are going to get minus 3. And we can see that if you pick 7 and 10, when you multiply 7 and 10, you are going to get 70. When you subtract 7 from 10, you are going to get 3. But in this case, the numbers we are looking for are when you multiply them, you should get minus 70. When you add, you should get minus 3. So it means that we have to do something about 7 and 10 such that they will fit what we want. Now, when that happens, what it means is that you have to either negate one of them or you have to negate all of them. So let's try and negate 7 and see. So when you make 7 negative, if you multiply negative 7 by 10, you are going to get negative 70. So that's satisfied. But when you add negative 7 to 10, you are going to get positive 3. So that won't satisfy the condition for the B. If that happens, don't negate the 7. Change it and negate the 10 and try and see. So when you negate 10, you are going to get 7 and minus 10. Now, when you multiply 7 by negative 10, you are going to get negative 70. When you add 7 to negative 10, you are going to get negative 3. So it means that this time, it means you have to pick 7 and negative 10. Sorry. Now, after you pick 7 and negative 10, the next step you have to do is to replace negative 3 with 7 and negative 10. So I'm going to clean the factors that I wrote here so that it doesn't interfere with what we are doing. Okay, so we can continue now. So you are going to replace negative 3. You are going to replace negative 3 with negative 10 and negative 7. So you place negative 3y here with negative 10y plus 7y. So you are going to have 7y squared minus 10y plus 7y minus 10. Then we continue and factorize as we have been doing all along. So here we factorize y out since y is the common factor there. So we are going to have y bracket open 7y minus 10, then plus, when we come here, you can see that they have nothing in common, so 1 will be outside the brackets. Then you have what is already here in the bracket, 7y minus 10. Now you can see that when you do this very well, always what is in the brackets will be the same. So we have 7y minus 10, 7y minus 10. So we pick one of them, then you pick y plus 1, which are outside the brackets, and you put them in one bracket. So y plus 1 in one bracket, then 7y minus 10 in another bracket. Let's pick another example. X squared minus 2x minus 3. Now, the first thing that we have to do is that we know that in this case, a will be 1 since we have 1x squared. So you multiply 1 by minus 3, and we know that that is giving us minus 3. Now, we are looking for two numbers that when you multiply, you get minus 3. When you add, you are going to get minus 2. Those two numbers will come from the factors of 3. You know that since 3 is a prime number, the factors of 3 are 1 and 3. So what you have to do is that it means that we have to change one of these to negative, since when you multiply them, you should get negative 3. Now also bear in mind that when you add them, you should get negative 2. When you multiply them, you should get negative 3. But when you add them, you have to get negative 2. So if that is the case, then it means that we have to negate 3. Because when we negate 3, 1 times negative 3 will give us negative 3. 1 plus negative 2 will give us negative 2. So it means that we have to negate the 3. Now we found those two numbers to be 1 and negative 3. So you replace negative 2 with those two numbers, 1 and negative 3. So if you are replacing negative 2 with those two numbers, you are going to have x squared minus 3x plus 1x minus 3. But we know that 1x is already 1, so you don't write the 1 there. You put the brackets around them, then you simplify. So you factorize, so you are going to factorize x out in this case. When you factorize x out, you are going to have x minus 3 in the brackets, then plus, we know that x minus 3 is already here. So you put 1 in front of the bracket, then we have x minus 3 already in the bracket. So you have x minus 3 here, we have x minus 3 here. So So you pick one of them. Then we have x plus 1 outside the bracket. You pick those ones and put them in the bracket. So you have x plus 1, which are x plus 1, then x minus 3, x minus 3. You pick one of them in the bracket here. Thank you very much for watching this video. See you in the next video, where we will continue solving the examples on quadratic trinomials in this video. Bye bye. The topic we are treating today is algebraic expressions. In the previous video, we learned how to factorize quadratic trinomials and we took some examples on it. In this video, we are going to continue solving examples on quadratic trinomials. So we begin with the fourth example. We have x squared plus 2x plus 1, and we are being told to factorize this trinomial. Just as we did in the previous video, we know that if you want to factorize a quadratic trinomial, the first thing that you have to do is to multiply the coefficient of the quadratic term, which in this case is the x squared, and we know is 1, with the constant, which is plus 1 in this case. So we are multiplying a by c. So in this example, 1 will be our a, 2 will be our b, and 1 will be our c. So you multiply a by c. So you are going to multiply 1 by 1, and we know that that is 1. So we are looking for two numbers that when you multiply, you get 1. When you add, you are going to get 2. You will get that from the factors of 1. And we know that the factors of 1, there's only one factor of 1, which is 1 itself. So the two numbers we are looking for are 1 and 1. Because if you multiply 1 by 1, you are going to get 1. If you add 1 to 1, you are going to get 2. So as soon as you find that, you replace 2 here with 1 and 1. So we have 1s and 1s. We know that 1s is the same as x. So you put the brackets around it and you factorize. So here you factorize x out. You are going to get s out, x plus 1 in one bracket, then plus you have s plus 1 in the other bracket. So you can see from here that s plus 1 is here, s plus 1 is here. So you pick one of them. You have s and plus 1 outside the bracket. So you pick those ones and you put them also in the bracket. So first you pick s plus 1 outside the bracket. Then s plus 1 here, s plus 1 there. You pick one of them. So you are going to have s plus 1 in one bracket, s plus 1 in the other bracket. Let's continue with the next example. 3x squared minus 10x minus 13x plus 10. So 3 will be a, minus 13 will be b, and 10 will be c. So you multiply a by c. So you are going to have 3 times 10, and we know that that is going to give us 30. So we are looking for two numbers that when you multiply, you get 30. But when you add, you are going to get minus 13. And we say that you will find those two numbers from the factors of 30. You know that the factors of 30 are 1, 2, 3, 5, 10, 15, and 30. So you look through this and you will see from here that when you multiply 3 by 10, you are going to get, when you multiply 3 by 10, you are going to get 30. When you add 3 to 10, you are going to get 13. So you pick those two numbers, 3 and 10. But you can see from here that when you multiply them, you should get 30. When you multiply, you are getting 30, so that is right. But when you add them, you should get minus 13. But when you add 3 to 10, we are getting plus 13. So it means that we have to negate both of them. So you negate 3, you negate 10. Remember, when you multiply negative 3 by negative 10, you are getting positive 30. So that will satisfy that condition. When you add negative 3 to negative 10, you are going to get negative 13. So that will also satisfy this condition. So the two numbers we are looking for are negative 3 and negative 10. Now, as soon as you find that, you are going to replace negative 13 here with negative 3 and negative 10. So you are going to have 3x squared minus 3x minus 10x plus 10. Then you continue with the factorization. So here we factorize 3x out. So you factorize 3x out, you have x minus 1 in the bracket. Then when you come here, you factorize 10 out. Now remember that when you were studying factorization of algebraic expressions, I said that whenever you have a negative sign outside the bracket and you factorize something out, if the sign in the bracket is positive, it changes to negative. If that sign is negative, it changes to positive. So here we have a negative sign outside the bracket. We factorize 10 out. The sign inside the bracket was positive, so it's going to change to a negative sign. So you can see from here that we have minus 1 in this bracket. We also have minus 1 in that bracket. So you pick one of them, then you pick 3x and minus 10 in another bracket. So 3x minus 10 in one bracket, then x minus 1 in another bracket. Then you move on to the next example. This looks quite different, right? We have 3x squared plus 7sy minus 6y squared. So you can see from here that we have two quadratic terms. Now this changes nothing. Solve it just as we would do when we are solving the previous ones. So in this case, 3 will be our a, 7 will be our b, and minus 6 will be our c. So you multiply a by c. If you multiply a by c, in this case you are going to get 3 times minus 16. You are going to get minus 6. You are going to get minus 18. Now we are looking for two numbers that when you multiply, you get negative 18. But when you add them, you are going to get positive 7. You will get those two numbers from the factors of 18. So you begin by listing the factors of 18. And we know that they are 1, 2, factors of 18, 1, 2, 3, 6, sorry. So 1, 2, 3, 6, 9, and 18. Now when you look through this, you can see that if you pick 2 and 9, you multiply them, you get 18. When you subtract 2 from 9, you are going to get 7. So those two numbers we are looking for are 9 and 2. But we can, as we can see from here, when you multiply them, you should get minus 18. When you add them, you should get 7, which means that we have to negate 2. Because if you negate 2, we are going to have 9 minus 2 will give us 7. 9 times minus 2 will give us minus 18. So you have found those two numbers to be 9 and 2. So we are going to replace 7 here with 9 and 2. So we are going to have 3x squared plus 9xy plus 9xy minus 2xy minus 6y squared. So we have just replaced 7xy with 9xy and minus 2xy. You proceed to simplify from here. So you put the brackets around it. Here the common factor we have are 3x. So 3x will come out. Then we have x plus 3y in this bracket. Then here the common factor will be minus 2y. So minus 2y will come out. We have x plus 3y in this bracket. If you watch the video on factorization of algebraic expressions, you understand how we are doing these factorizations. So we can see from here that we have x plus 3y in this bracket, x plus 3y in this bracket. They are the same. So you pick one of them, then you pick 3x and minus 2y in another bracket. So you have 3x minus 2y in one bracket, x plus 3y in the other bracket. Let's take the last example. We have 2a squared minus ab minus 3b squared. So we can see from here that the coefficient of ab here will be 1. So 2 will be a, 1 will be b, and negative 3 will be c. So we have a being 2, negative 1b, and negative 3 will be c. So you multiply a by c. So we multiply 2 by negative 3, and we are getting negative 6. If you multiply 2 by negative 3, we are getting negative 6. Now we are looking at two numbers that when you multiply, you get negative 6. When you add, you are going to get negative 1. And we are going to get those two numbers from the factors of 6. We know the factors of 6 are 1, 2, 3, and 6. Now, when we look at this very carefully, we know that if you pick 2 and 3, now when you multiply them, you get 6. When you subtract 2 from 3, you are going to get 1. So we can change one of these such that it fits what you want. We want two numbers that when you multiply them, you are going to get negative 6. When you add, you are going to get negative 1. Which means that if we negate 3, that is, we have 2 and negative 3. When you multiply them, you are going to get negative 6. When you add them, you are going to get 2 minus 3, which is negative 1. So we are now changing it to fit what we want. As soon as you have 2 and negative 3, you replace them. You replace negative AB here, or negative 1 AB here, with 2 and negative 3. So you're going to have 2a squared plus 2ab, which is for the 2 here, then minus 3ab, which is for the minus 3 here, then minus b squared comes as the final term. You proceed to simplify from here. So you put the brackets around it. Here we factorize 2a out. We are going to get into brackets 2a into bracket a plus b. Remember, there's a negative sign here. So as soon as you factorize something out, the sign in the bracket, which is negative, must change to positive. So here we factorize 3b out, since it's the common thing here. So you factorize 3b out. You're going to get a plus b. Once again, the sign is changing because we have a negative sign in front of the bracket. As I said, if you have a negative sign in front of the bracket and you factorize something out, the sign between the terms in the bracket, if that sign is positive, it changes to negative. If it's negative, it changes to positive, as we have here. So we have a plus b in this bracket. You also have a plus b in that bracket. So you pick one of them, then you pick 2a minus 3b, and you put them in another bracket. Thank you very much for watching this video on factorizations of quadratic trinomials. We could see from these two videos that you've watched, this video and the previous one, that the main thing when factorizing a quadratic trinomial is finding the two numbers that you replace the b with. Now, in the next video, I'm going to show you a trick how to use your calculator to generate those two numbers. See you and bye-bye. The topic we are treating today is algebraic expressions. In the previous video, we learned how to factorize quadratic trinomials. In this video, we are going to learn how to use the calculator to find the two numbers when you are factorizing quadratic trinomials. So let's pick an example and see how it's done. I'm going to use this type of calculator in this video. So this is the type of calculator that I'll be using. Now, let's see how it's done. You have been told to factorize the trinomial x squared plus 7x plus 12. Now, as usual, we know that to factorize this trinomial, you multiply the coefficient of x squared by 12. The coefficient of x squared is 1, so you multiply that by 12 and you are going to get 12. Then you find the numbers that two numbers that when you multiply, you are going to get 12, and when you add them, you are going to get 7. So these two numbers, they are what I'm going to teach you how to use the calculator to find them. Now, to begin the whole process, this is what you have to do. First, write down the values for a, b, and c. So as we learned in the previous video, the value for a in this question is 1. The value for b in this question is 7, and the value for c in this question is 12. Then you multiply a by c. You know that a is 1 and c is 12, so if you multiply 1 by 12, you are going to get 12. Then you move on to your calculator and you punch this equation on the calculator. Now this is how to do it. Press on mode. After you switch on the calculator, press on mode, then pick equation. Equation is the fifth option, so you pick equation. Then you pick quadratic equation, that is the third option. So the third option will give you quadratic equation. So you can see from here that on the calculator it's asking you for A, B, and C. So first you input A. We know that A is 1. So you press 1. Then you press equal to. It's asking you for B. B is 7. So you press 7 and you press equal to. It's asking you for C. C is 12. So you press 12 and you press equal to. Then finally you press equal to. So it's going to give you the first answer, which is usually called the S1. Now we can see from here that S1 is negative 3. Whatever answer that the calculator give you, if that answer is negative, pick it as positive. If that answer is positive, pick it as negative. So here the answer the calculator gave us was negative 3. So you are going to pick it as positive. So pick that as positive 3. Now when you have your first number, which is positive 3, multiply that what you obtain from the calculator with A. In this case, A is 1. So if you multiply 1 by 3, you are going to get 3. That will be your first number. So the first number is 3. So this is how to find the first number. Punch the equation on the calculator. The value of x1 that will be given to you, if that value is negative, pick it as positive. If it's positive, pick it as negative. In this case, it was negative 3. So pick it as positive 3 and multiply that with the value of A. In this case, the value of A is 1. So multiply 3 by 1 and that will give you 3. That is your first number. Then if you want to find the second number, divide A times C by the first number. So you already know that A times C in this case is 12. So divide that by the first number, which is 3, and that is going to give you 4. So your second number is going to be 4. Let's take another example. We have y squared minus 3y minus 10. So we know from here that A is 7, B is equal to minus 3, and C is equal to minus 10. Then as we said, multiply A by C, sorry. So 7 times minus 10 will give us minus 70. Now you go on to the calculator and you punch the equation into the calculator. So as I said, you press on mode, you pick the fifth option, then you pick 3, which is quadratic equation. So A is 7. You press 7 and you press equal to. B is negative 3. So you press negative 3, you press equal to. C is negative 10. So you press negative 10 and press equal to. Then the final equal to. So you see from here that S1 is giving us 10 over 7. As I said, the answer that will be giving you, if it's positive, pick it as negative. If it's negative, pick it as positive. So here is giving us positive 10 over 7. So we are going to pick it as negative 10 over 7. Then after you picked it as negative, multiply that number by A. In this case, A is 7. So we are going to have negative 10 over 7. We multiply that by A, which is 7. You know that 7 will cancel 7, giving us 10. So the first number will be negative 10. Now this is how to find the second number. Divide A times C. In this case, you know that A times C is negative 70. We have that here. Divide A times C by the first number. The first number is negative 10. A times C is negative 70. So you are going to have negative 70 divided by negative 10. So negative is going to cancel negative. Then you are going to have 70 divided by 10, which is 7. So the second number will be 7. So the two numbers that you need are negative 10 and 7. Let's pick another example. So in this example, A is 1, B is negative 2, and C is negative 3. So A times C will give us negative 3. A times C will be negative 3. Sorry. So you go on to your calculator. Then you press on mode, pick equation, then you pick the third option. So it's asking you for A. We know that A is 1, so you press 1 and you press equal to. B is -2, so you press -2, press equal to, and C is -3, so -3, and you press equal to, then you press the final equal to. So the first value we are getting is 3. This is positive, so we are going to pick it as a negative. So the first value we obtained was 3. Now if you get 3, multiply that with the coefficient of x squared. In this case, multiply that with a. So -3 times 1 will give us -3. So it means that in this case, the first number that we are having is -3. Now to get the second number, divide a times c. In this case, a times c is -3. Divide that by the first number. So the first number is -3. A times c is also -3. So you are going to have -3 divided by -3, which will give us 1. So the second number is going to be 1. So the two numbers we are looking for are -3 and 1. So we just replace them. We just replace those two numbers with -2x. Now in this example, we know that A is 3, B is -13, and C is 10. So you go on to your calculator, then you feed in these values into the calculator. So press on mode, you press equation, then you press the third one. Then you know that A is 3, so 3, B is -13, so -13, C is +10, so +10, then you press equal to. The first value we are obtaining is 10/3. Once again, if that value is positive, pick it as a negative number. So you are going to have -10/3. The calculator gave us 10/3, so you are going to pick it as negative, which is -10/3. So multiply that number by a. In this case, a is 3, so you are going to have -10/3 by a, which is 3. That 3 is cancelling 3, which will give us -10. So the first value that we are having is -10. Now to get the second value, first find a times c. A times c is 3 times 10, which is 30. Now divide a times c by the first value, which is -10. You know that 30 divided by -10 is going to give us -3. So the two numbers we are looking for are -10 and -3. Now we move on to the next example. We have 3x squared plus 7xy minus 6y squared. So once again, from here we know that a will give us 3, b will give us 7, and c will give us -6. So you go onto the calculator and you feed this information into the calculator. So to find equation, press on mode, press on 5, then choose the third option as your quadratic equation. So we know that a is 3, b is 7, and c is -6. So you can see from here that the first value we are getting is 2/3. 2/3, positive 2/3. So we are going to pick that as negative. So we are going to pick it as -2/3. Then you multiply that value with a to obtain your first value. So -2/3 times a, which is 3. 3 will cancel 3. We are going to get -2. So the first number is -2. To get the second number, first find a times c. A times c will give us 3 times -6, which is -18. So we are going to have -18. Now divide a times c by the first number, which is -2. We are going to have negative will cancel negative. Now 18 divided by 2 is going to give us 9. So the two numbers we are looking for are +9 and -2. Thank you so much for watching this video. Pick more examples and try using the calculator to find the two numbers. following the same principles that we did in this video. See you in the next video, where we will learn how to divide and multiply algebraic expressions involving fractions. Bye bye. We are on the topic algebraic expressions. In the previous video, we learned how to factorize quadratic trinomials. In this video, we are going to learn how to multiply and divide algebraic expressions involving fractions. So, we have some examples to learn how to do that. We are being told to simplify the following, and we have been given from question 1 up to question 6. So we take them one after the other and learn how to multiply and divide algebraic expressions involving fractions. So let's begin with the first one. We have 3x squared over 4y squared times 2y raised to the power 3 over 9x. So the main goal we have here is to multiply the numerator with the numerator and the denominator with the denominator. But if you have common factors, you first have to cancel the common factors out. So a common factor on the numerator will cancel a common factor on the denominator, and a common factor on the numerator here can cancel a common factor on the denominator. In the same way, a common factor on the numerator here can cancel a common factor on the denominator here, and a common factor on the numerator here can cancel a common factor on the denominator here. So the first thing that you have to do is to check out for common factors. So how is that done? Now, we can see in this example that we have 3 here. Now you have 3 on the numerator here. There is 9 on the denominator here. We know that 3 and 9, 3 is a common factor of 9. So 3 can cancel itself 1 and cancel 9 3 times. Now we also have s on the denominator here. We have s squared on the numerator here. So s will cancel itself and cancel one of the x's here, so that we have just s raised to the power 1. So we can see from here that there is no x again to cancel. So we move on to the other side. Now we have 2 on the numerator here. So 2 can cancel itself 1 and cancel 4 on the denominator here 2 times. Now we know that we have y raised to the power 2 here and y raised to the power 3. So y raised to the power 2 can cancel itself 1. It will cancel y raised to the power 3. It will take 2 out of the 3 so that we have 1. If you watch the video on indices, you are going to understand this very well. So you can see from here that we've cancelled all the common factors out, such that the numerator is now s. So the denominator here is now s. The denominator, everything is gone. We are now left with 2, because we are going to have 2 times 1, which is 2. When you come here, we've cancelled 2, so 2 cancels itself 1. Here the y raised to the power 3 cancelled y. Here the y raised to the power 2 cancelled y raised to the power 3. So we are having only y raised to the power 1, which is 1. So we have 1 times y, which is y, and here everything cancelled and we've got 3. So we are going to have s over 2 times y over 2. Now, since this is in the simplest form, you multiply s with y, that is the numerator multiply the numerator, the denominator multiply the denominator. S times y in algebra is written as sy. 2 times 3 is 6. So we have xy over 6. So we have simplified this. Let's take the next example. Now whenever you have something like this, we have a over as plus 2a squared times s squared minus 4a squared all over x minus 2a. As we did in the previous example, what you have to look for are common factors so that you can cancel out. Now whenever you have something like this, what should come to your mind is that you have to factorize something out so that you can cancel. So you begin by factorizing out. Now when you come to this part, here is a, so you can't factorize anything there. So but when you come here, you know that we have a here, we also have a here. So a is a common factor, so we can factorize that out. So we are going to have a into bracket s plus 2a. Then we come to this side. Now when you come here, you can see that we have x minus 4a squared. We learned that whenever you see something like this, you should begin to think of difference of two squares. Now we can change 4 to 2 squared. Now immediately we change 4 to 2 squared. We can write this as a over a into bracket s plus 2a times x minus 2a all squared over s minus a. Now s minus 2a all squared is a difference of 2 squares, so let's write that in its general form. Now when you write it, we know they are going to get a over a into bracket s plus 2a times s minus 2a in one bracket, s plus 2a in the other bracket, all over x minus 2a. So this is how to expand this difference of 2 squares. If you watch the video on the principles of difference of 2 squares, you are going to get this. Now since we factorize everything out, you look for common factors and cancel. So we can see from here that a here is a factor, so a can cancel a. Remember, what is on the numerator cancels what is on the denominator. Now when you come here, we have x minus 2a as a common factor. We have s minus 2a here, so s minus 2a in the here can cancel this s minus 2a. Now when we come here, we also know that we have s plus 2a here, and we have another s plus 2a here. So s plus 2a on the numerator can cancel s plus 2a on the denominator. So you see everything is cancelled out. So this one cancels itself. You are going to get 1. Here a will cancel itself 1. Here is 1. So you are going to get 1 times 1. Here this one will cancel itself 1. Here is 1. So we are having 1 times 1. And here is 1. So we are going to have 1 over 1 times 1 over 1. You know that 1 over 1 times 1 over 1 is 1, because you are going to have 1 times 1, which is 1. Let's move on to the next example. Just as we did for the previous example, in this example also, we are going to factorize some common factors out so that we can cancel. So we look at the first one. This looks like something we can factorize, right? So we can factorize 2x out. So we factorize 2x. The numerator is going to give us 2x into bracket 3x plus y, all in bracket, then over 5x times 15 over 5z times 15z squared over 3x plus y. So we can see right away from here that we can cancel some things out. We can see from here that 5 is here. 5 can cancel itself 1 and cancel 15 3 times. Now we see z here, we see z squared here, so z can cancel z squared. This will cancel one of the z, so that we have z raised to the power 1. We have 3x plus 1 plus y as a factor here, so 3x plus y here can cancel 3x plus y here. So here will also cancel itself 1. So we are going to have 2x over 1, since everything here is cancelled, times 3z. Remember here was z squared, and this z cancelled one of them, so 3z over 1. So we are going to have 2x times 3z all over 1. We are going to have 6z xz. Remember that when we are multiplying, the coefficients will multiply, so 2 will multiply 3. We are going to have 6. Then you have x and z. Now let's pick the next example. This is on division. So we have 4a squared plus 8ab all over 3 divided by 5ab plus 10b squared all over 9. Now whenever you have a division, this is what you have to do. Keep what is on the left hand side. Now this is what I mean by what is on the left hand side. Here is the left hand side, and the one here is on the right hand side. So I'm using LHS for left hand side and RHS for right hand side. Keep what is on the left hand side like that, and reciprocate what is on the right hand side. When I say reciprocate, I mean that turn it upside down. So if you have a over b divided by c over d, this is what I mean. Keep what is on the left hand side, so keep a over b. Change the division sign to multiplication and rotate what was here, so d over c. So that is the exact thing we are going to do here. We are going to keep what was on the left hand side. So here I'm going to clean this so that you get what I want to do. Okay, so we will keep what was on the left hand side, which is 4a squared plus 8ab all over 3. We will keep that. Then we will rotate what was on right hand side, what was on the right hand side. So the numerator will now become the denominator, and the denominator will be the numerator, as we are shown here. So we turn it upside down. So whenever you have a division, keep what is on the left hand side, change the division to multiplication, and turn what was on the right hand side upside down. Now from here we can continue as we have been doing for the division. So this is what we are going to do. We look for common factors and we cancel out. So first, let's factorize. We can see from here that we can factorize 4a out. So if you factorize 4a out, you are going to have 4a into bracket a plus 2b all over 3 times 9 over, here we factorize 5b out. So 5b into bracket a plus 2b. Now let's cancel out. So 3 will cancel itself 1, cancel 9 3 times. You can see that we have 2 plus ab as a factor here, 2 plus ab as a factor. So 2 plus ab will cancel this 2 plus ab. So this is now in its simplest form. So we are going to have, we are left with 4a here. The denominator here is 1, so we are going to have 4a over 1 times, here when 3 cancelled it, we are left with 3. So 3 over, we cancelled a plus 2b out, so we now a plus 2b out, so now we now have 5b here. So we are going to have the numerator multiplying the numerator, the denominator multiplying the denominator. So 4a times 3 all over 1 times 5b, and that is going to give us 12a all over 5b. Let's take the next example. We have 4y squared minus 15y minus 4 all over 3y squared minus y minus 4 divided by 4y squared minus 3y minus 1 all over 3y minus 7y plus 4. This looks long, but it follows the same principle that we have done. We've learned how to factorize quadratic trinomials, and we are going to use that a lot in this example. So just as we did for the previous video, this is an example of division. So you keep what is on the left hand side, which means that you are going to keep the left hand side, the first part. You change the division sign to multiplication. Then you rotate what was on the right hand side, you turn it upside down. So what was on the numerator side will come as the denominator, and what was on the denominator will come as the numerator, as we can see here. Now the next step is to factorize. These are quadratic trinomials, so you factorize using the same principles as quadratic trinomials. You know that to do it for this, you multiply 4 by 4, you are going to 4 by negative 4, you are going to get negative 16. So we are looking for two numbers that when you multiply you get negative 16, when you add you get negative 15. Those two numbers will be negative 16 and 1. So you place negative 15 with those two numbers, as you can see here. You do the same factorization for this part, you do it for this part, and you do it for this part, as we can see in this example. We learned more about this in the video on quadratic trinomials. So if you are facing any difficulty, I would advise that you watch that video, then you continue on from there. So from here, when we factorize these out, we are going to have the numerator part for this 4y plus 1 in one bracket, 4 minus y minus 4 in another bracket, divided by 3y minus 4 in one bracket, y plus 1 in another bracket, times 3y minus 4 in one bracket here, y minus 1 in one bracket here, 4y plus 1 in one bracket, y minus 1 in another bracket. Now since these are all factorized out, we look for common factors to cancel. So we can see that we have 4y plus 1 here, we have 4y plus 1 here, so we can cancel. We have 3y minus 4 here, we have 3y minus 4 here, so we can cancel. Then we have y minus 1 here, we have another y minus 1 here, so we can cancel. So everything here is cancelled, so it means that we are having 1. Here is cancelled, we have 1, here is cancelled, we have 1. So we are going to have 1 times 4 minus y minus 4, which is y minus 4, all over 1 times y plus 1, which is y plus 1. Remember that the whole place here is 1. If you multiply this by 1, you are going to have y minus 4 over y plus 1. Now remember that here we can't cancel y out because it is not a common factor. So unless before you can cancel, make sure that you have factorized it out before you can cancel. Let's take the last example. We have x squared minus y squared all over x minus y all squared. So here you use the principles of difference of two squares. When we watched that video, we saw that if you have x squared minus y squared, if you use the principles of difference of two squared, x squared minus y squared will give us x minus y in one bracket, x plus y in one bracket. We also know from indices that x minus y all squared is the same as x minus y in one bracket, x minus y in another bracket. So from here we can see that x minus y is a common factor, x minus y here, so they cancel out. So we will now have x plus y over x minus y. Remember, we can't cancel either x or y because they are not common factors, and we can't cancel the whole thing because here is x plus y, here is x minus y, and they are different. Thank you for watching this video. Take more examples of multiplication and division of algebraic expressions involving fractions. See you in the next video, where we will learn how to add and subtract algebraic expressions involving fractions. Bye bye. We are on the topic algebraic expressions. In the previous video, we learned how to multiply and divide algebraic expressions involving fractions. In this video, we are going to learn how to add and subtract algebraic expressions involving fractions. So let's pick some examples and see how this is done. We are being told to simplify the following, and we have been given from question 1 up to question 5. So we take them one after the other and solve it. So we pick the first one. We have a minus b over 2 plus 2a over 3. Now, solving algebraic expressions involving fractions is the same as addition and subtraction of fractions, as we already learned in the video on fractions. So the first thing that you need to do is to first find the LCM of the fractions given to you. So here the LCM, the denominators we have are 2 and 3. So we find the LCM of the denominators. So we find LCM of 2 and 3, and we know that that is 6. Now we found that to be 6. We know that when we are doing fractions, we will divide 6 by 2. So 6 divided by 2 will give us 3. We will multiply that with the numerator of that part. So the numerator of this part is a minus b. So 6 divided by 2, which is 3, you multiply that with the numerator, which is a minus b. Now because we have two terms here, a minus b, we put them in brackets such that we don't get confused during the multiplication. We already have the addition sign here, so we bring that addition sign, so plus. When you come here, you will divide 6 by 3. That is the denominator of this part. So 6 divided by 3 will give us 2. We multiply the results with the numerator, which is 2a. So from here, we do the expansion of the bracket. So 3 times a will give us 3a. 3 times minus b will give us minus b. Then plus 2 times 2a will give us 4a. You group like terms and you do the addition. So 3a plus 4b minus 3b. Since 3a and 4a are like terms, so 3a plus 4a minus 3b all over 6. You know that 3a plus 4a will give us 7a minus 3b all over 6. So since this is the simplest form, we end here, and this is our final answer. Let's look at the second one. We have 2x minus 1 all over 3 minus x plus 3 all over 2. So once again, you look for the LCM of the denominators. So the denominators here are 3 and 2. So the LCM will be 6. Now you go again. 6 divided by 3 will give us 2. So 6 divided by 3 giving us 2. You multiply the results with the numerator. The numerator is 2x minus 1. Once again, you put it in brackets since you have two terms here. Then we already have the negative sign here, so the negative sign must come. 6 divided by 2 will give us 3. You multiply that with the numerator here, which is x plus 3. So from here you expand the bracket. 2 times 2x will give us 4x. 2 times minus 1 will give us minus 2. 3 times x will give us minus x. Minus 3 times 3 will give us 9 all over 6. You group like terms and you continue. So when you are grouping like terms, you are going to have 4x minus 3x minus 2 minus 9 all over 6. If you watch the video on addition and subtraction of algebraic expressions, you understand how we are doing the addition and grouping of the like terms. You know that 4x minus 3x will give us x, minus 2 minus 9 will give us minus 11 all over 6. We move on to the next one. We have 3 over x plus 1 minus 2 over x minus 1. Now we can see that this is a little bit different because we have the denominators involving variables. Now whenever you have the denominators involving variables, the LCM of the denominators is the product of the denominators. So here you multiply x plus 1 by x minus 1 and use it as the LCM. So the LCM here is going to be x plus 1 times x minus 1. That is what you are going to use as the LCM. Now, how do you proceed from here? Remember when we were doing the previous one, we said that to find this here, you divide the LCM by the denominator here. So here the LCM is x plus 1, x minus 1. Now, the denominator here is also x plus 1. So you divide that by x plus 1. And you know that this one is cancelling this. So the remainder will be x minus 1. Then you multiply the numerator, which is 3, by the remainder, which is x minus 1. Then you bring your negative sign. Then you come to this side. When you come here, the denominator is x minus 1. So you are going to divide the LCM, which is x plus 1 in one bracket, x minus 1 in the other bracket. So this is x, this is plus. You are going to divide that by x minus 1. You know that x minus 1 will cancel x minus 1, so you'll be left with only x plus 1. Then the numerator will multiply that, which is 2 times x plus 1. So you proceed with the expansion and you simplify as we have been doing all along. So 3 will multiply x, we are going to get 3x. 3 times minus 1, you get minus 3. Minus 2 times x, you are going to get minus 2x. Minus 2 times 1 will give you minus 2 all over the LCM. So you proceed. You are going to have 3x minus 2x minus 3 minus 2 when we group like terms. 3x minus 2x will give us x, minus 3 minus 2 give us minus 5, then x plus 1 in one bracket, x minus 1 in the other bracket as the denominator. Now we move on. We have x over x minus 2 over x minus 2 plus x over x squared minus 4. Now immediately we can see that x squared minus 4 looks like difference of two squares. Now whenever you have that, first expand the difference of two squares. So we have 2 over x minus 2 plus x over x squared minus 2 squared, since 4 is the same as 2 squared. So if you expand this, you are going to get x over x minus 2 plus 2 over x minus 2 plus x over x minus 2 into one bracket, x plus 2 in the other bracket. Now you can see from here that in the previous example I said whenever you have a variable in the denominator, you are going to, the LCM is going to be the product of the denominators. But you can see from here that x minus 2, which is the denominator here, is already in this part. Now if that happens, you pick the one that already contains the term. So you can see from here that x minus 2 is already contained in this part. So there is no need multiplying the denominator here with the denominator here, because x minus 2 is already here. So in this case, the denominator is going to give us x minus 2, x plus 2, since you can already find x minus 2 here. So you continue with the simplification. We are going to divide the LCM here with this. So the LCM that we have is x minus 2 in one bracket, then x plus 2 in one bracket, divided by the denominator here, which is x minus 1. So which is x minus 2. So you can see from here that this x minus 2 will cancel this x minus 2, and we are left with x plus 1. The numerator is 2, so you multiply 2 by the result, which is 2 into bracket x plus 2. Once again, you are putting x plus 2 in a bracket because there are 2 terms there and 2 is only 1 term. Now we come to this part. For this part, the denominator is x minus 2, x plus 2, and the LCM is also x minus 2, x plus 2. So if you divide the denominator by the LCM, we are going to see that we will have 1, because x minus 2 in one bracket, x minus 2 in one bracket, then x plus 2 in the other bracket, divided by x minus 2 in one bracket, then x plus 2 in the other bracket. You can see from here that x minus 2 will cancel x minus 2, x plus 2 will cancel x plus 2, so the result will be 1. Then you multiply that 1 by the numerator here, which is already x. Then you open the bracket, so you are going to have 2 times x, which will give us 2x, 2 times 2, which will give us 4, then x times 1, which will give us x. So you group like terms. We are going to have x plus x, which will give us 3x plus 4 all over x minus 2 into one bracket, x plus 2 in the other bracket. Let's take the final example. We have 2 over x minus 2 minus x plus 1 all over x minus 2 in one bracket, x minus 1 in the other bracket. Now we can also see from here that we have x minus 2 here, and that x minus 2 can also be found here. So in this case, the LCM will be this. Because we can find x minus 2, which is the denominator here, we can already find it here. This part is going to be the LCM. So x minus 2, then x minus 1 is going to be the LCM. Now we can see from here that if you divide x minus 2, x minus 1 by x minus 2, you are going to have x minus 1. The numerator is 2, so you multiply 2 by x minus 1. Once again, you put x minus 1 in a bracket because it is a binomial and is being multiplied by a single term, which is 2. Then when you come here, you are going to have x minus 2, x minus 1, dividing x minus 2, x minus 1, and our answer is going to be 1. There is this negative here because there is a negative sign already between them. Then into bracket, so you are going to multiply that 1 by the numerator, and the numerator is x plus 1. So we expand the brackets from here. 2 times x will give us 2x. So from here we can see that 2 times x will give us 2x. 2 times minus 1 will give us minus 2. Minus 1 times x will give us minus 1. Minus 1 times 1 will give us minus 1. So we group like terms. You're going to have x minus 1 minus x minus 2 minus 1 all over x minus 2 into one bracket, x minus 1 in the other bracket. Now x minus x will give us x. Sorry, 2x minus x will give us x. Minus 2 minus 1 will give us minus 3. You divide that by x minus 2, x minus 1. Now remember here that we can't cancel any further because there is no common factor here. Thank you for watching this video and all the videos on algebraic expressions. This is the end of the topic algebraic expressions. Pick more examples on this topic and try your hands on them. Use the principles that you use in this video. If you have any question, interact with me on my social media handles and I'll help you to solve those questions. Bye bye.